The topic of this week is trusses, framing structures. Trusses are rigid, geometrically unchangeable framing structures. When we have to consider the structures of bridges, rafters, and various crane designs, we are to deal with the problem of designing and calculating trusses. One of the most famous trusses is the Eiffel Tower. The contemporary use of trusses can be observed as we watch additional modules being delivered to the International Space Station. These modules are linked up to the space station and are used for arranging the disposal of additional equipment and solar batteries. The problem to be solved when designing such trusses is to define external constraints and the forces in the bars and members of the trusses. To solve this problem, additional simplification hypotheses are introduced, such as the bars are assumed to be ideal and the load is assumed to be concentrated in the joints of trusses. With these assumptions, the problem is deemed statically determinate if the number of bars and the number of joints are correlated with the following relationship. By the example of this truss, we can see that the number of joints is 14 and the number of bars is 25. Thus, the truss is statically determinate. Imagine that we have removed one of the structure's members, and then the building structure turns into a mechanism.